Hello, welcome you for the 47 and 48th session of Z transform. As you all know that we are doing Z transform from past four session. This is the fifth and sixth session as per your syllabus. In this PPT, I will present initial value problem and inverse Laplace transform. So what is initial value problem? First we will see that, then we will go for the okay. If z transform of un is equal to u bar of z, then limit of u bar of z is equal to u naught. Now to prove this one, let me try to define once again the z transform. Z transform is equal to n is equal to 0 to infinity even z to the power minus n. Now when I substitute the summation values, first I will put n value as 0, so I will get u naught. Second time I will put n as 1, so u1 z to the power minus 1 and u2 z to the power minus 2 and so on. So now according to this initial value problem, what you have to do is that apply both sides the limit. So I have applied the limit and I rewrote the RHS of previous step as in this follows. Limit of z tends to infinity is equal to u naught plus u1 by z. Whatever u1 z to the power minus 1 is there, I wrote as u1 bar u1 divided by z and u2 divided by z square and so on. So when you apply the limit for this, you see that u1 divided by infinity is nothing but you will get as 0, u2 also 0, so left out is only u0. That is the required answer of the theorem. Initially this is the way I can find u0 and I can find similarly u1. Once again rewriting the given equation whatever just we have done in previous step, u0 plus u1 z to the power minus 1 plus u2 z to the power minus 2 plus dot 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 is there. Now what I will do is that u0 I will take to the left hand side. If you take left hand side, it looks like u bar of z minus u0 is equal to u1 by z plus u2 by z square plus dot dot dot. Now apply before going to the limit, let me go for the z. One z I have took to the left hand side, so left hand side if you take, you will get as u bar of z minus u naught of z is equal to u1 plus u2 z common I have took here. If you take common as in the second step, you see u1 z plus u2 z square is there. If you take z as in common over there, you will get only u1 plus u2 by z. Instead of z square, you will get as by z and so on. Now we will apply the limit for this. Yeah, if you apply the limit, you will get the value of u1. Similarly, I can write u2 in this fashion. Now the real thing will come. What is that real thing I want to do is, just you see that if u bar of z 2z square plus 3z plus 12 divided by z minus 1 whole to the power 4 is there, find the value of u0, u1, u2 and u3 is there. Yeah, u0 is given by, as we discussed in initial value problem, limit as z tends to infinity u bar of z. U bar of z they have given to us. u1 is calculated by this formula. You please see, limit z tends to infinity z into u bar of z minus u0. u2 is given by z square u bar of z minus u0 minus u1 by z. Lastly u3. That is 1, 2, 3, 4 equation I got. Now let me try to find what is the real value of u0, u1, u2 and u3. So u bar of z is equal to 2z square plus 3z plus 12 divided by z minus 1 to the power 4. We have by equation 1. How do you write? By equation 1 I can write as u naught is equal to limit as z tends to infinity u bar of z. U bar of z is given to us. Let me supply the values. U naught is equal to limit as z tends to infinity 2z square plus 3z plus 12 divided by z minus 1 whole to the power 4. Now try to apply this limit here. So to apply limit, what I have done is that I took numerator as z square, left out will be 2 plus 3 by z plus 12 by z square. In denominator also I took common as z, so z to the power 4 it is 1 minus 1 by z whole to the power 4. Now cancel it, so you will get as 1 by z square as an left out part. Remaining as it is, I wrote here 2 into 3 by z plus 12 by z square. Now you supply the limit on z. So limit of z is infinity. So what you will get, 1 by infinity is 0. So 0 multiplied 2 by 1 it is, answer is 0. So u naught value I got as 0. Now try to find by using the equation 2 u1. What is u1? u1 is given by equation 2, that is u1 is equal to limit as z tends to infinity z u bar of z minus u naught. u1 is equal to limit as z tends to infinity z 2z square plus 3z plus 12 z minus 1 whole to the power 4. Once again the same step what I have done is that I took z square as in common from the bracket. One more z is outside, so it will become z cube. This is what the simplification you can see, z cube into bracket 2 plus 3z 2 plus 3 by z plus 12 by z square 4 z to the power 4 1 minus 1 by z whole to the power 4. So it will get cancelled over here. We will get once again the answer as 0. Now we try to find u2. u2 is given by limit as z square u bar of z minus u naught minus u1 by z it is. u2 is equal to limit as z square u bar value I am taking as whatever is there, u bar of z is 2z square plus 3z plus 12 z minus 1 to the power 4 it is. u naught value is 0, u1 value is 0, so it is not going to contribute. So what is that one you will get here? If you take out 2 from z square as common from the bracket, it will get as z to the power 4 2 plus 3 by z plus 12 by z square. So here z to the power 4 z to the power 4 will get cancelled. Here we will get something answer as, so you place the limit value. When you place the limit value, you will get answer as 2, right? Now u bar of z is equal to 2z square plus 3z plus 12 z to the power minus z minus 1 whole to the power 4. We have the equation now. Yeah, this is the equation. Now I know what is u2. You just place the u2 value over there and u bar of z. So z to the power 3 2z square plus 3z plus 12 divided by z minus 1 whole to the power 4 minus 2 by z square. See, this step I have simplified 2 to 3 simplification. After arranging cancellation, after taking common, I end up with this z to the power 3 11z cube plus 8z minus 12 it is. If you take the common over here, z to the power 6 11 z to the power 8 by z square minus 2 by z to the power 3 divided by z to the power 6 1 minus z by 1 by z whole to the power 4. Now if you do this, what you will get, it is z to the power 6 z to the power 6 will get cancelled, so answer will be 11. So similar type of example I took here. 1 by so u bar of z is equal to 2z square plus 3z plus 4 z minus 3 whole to the power 3 is there. Show that u1 is equal to 2, u2 is equal to 21, u3 is equal to 139 we have to show. Anyhow, you just try to get what is u1, u0, u0 they have not asked, but they have not asked also. You have to calculate u0. Why? Because in u1 we need the value of u0. Therefore, you are going to calculate what is u0. Then after getting u0, u1 you can calculate by using the equation 2 u3, u2, u3. Okay, this is what just now we have done. Same thing is there. I will go fast little bit. U bar of z, it is what we will get here, 2z square plus 3z plus 4 divided by z minus 3 whole to the power 3. It is equation 1. Here you see that just I supplied u bar of z. U bar of z is what? 2z square plus 3z by plus 4 divided by z minus 3 whole to the power 3. So now you simplify by taking the common in numerator and denominator. What answer you will get? You will get answer as 0. Okay, now let me try to get what is u1. u1 is given by this formula. z cube will get cancel, and put the limit value over here. You will get answer as 2. So I know now what is u0 and u1. u0 is 0, u1 value as we got just now what it is 2, right? So now try to put all these values over here to get calculation. Now take the LCM and try to simplify it. Yeah, after taking LCM and simplifying, I got as z 21z square plus 50z plus 54 divided by z minus 3 whole to the power 3. So z square, if you take common outside, it will be z to the power 3, 21, 50 divided by z, 54 divided by z square. In denominator also same thing, common you took. Z cube will get cancelled, we will get 21. Now a1 value you know, u2 value is known to us. You just put the u1 value and u2 value and take the LCM and try to simplify. After LCM and try to simplify, we got this one as 139 z cube plus minus 513 z square plus 567 z divided by z minus 3 whole to the power 3 is there. Yeah, this is a simple set, you can do it. Now we inverse Laplace transform, as beginning in the cell set only I have told. Now inverse Z transform of Z by Z minus 1 is equal to 1. Inverse Laplace transform of 2 Z divided by Z minus K is K. Inverse Z transform of Z divided by Z minus 1 whole to the power 2 is N. Inverse Z transform of Kz divided by Z minus K whole to the power 2 is K to the power N into N. Same thing, inverse Z transform of Z square plus Z, Z minus 1 whole to the power 3 is N square. Same thing, we will get inverse Z transform of Kz square plus K square Z divided by Z minus K whole to the power 3 is equal to K to the power N square. And yeah, this is all known to you, just I'm giving a list for you. This is important. Z transform of Z by Z square plus 1 is equal to sine n pi by 2. Inverse Z transform of Z square plus 1. What is the difference here? In numerator Z square is there, then it will get as cos n pi by 2. Now find the inverse Laplace Z transform of Z divided by Z minus 1, Z minus 2. Now it is an partial resolving into partial fraction. I can rewrite this one, whatever the given equation is there, in this form. U bar of Z is equal to Z divided by Z minus 1, Z minus 2. I can also write the U bar of Z divided by Z, 1 divided by Z minus 1, Z minus 2. So 1 divided by Z minus 1 and Z minus 2 can be written as A by Z minus 1 plus B by Z minus 2. 1 is equal to, if you cross multiply, you will get 1 is equal to A Z minus 2 plus Z minus 1. Now try to put z is equal to 1 means if you put 1, what you will get here? B will get 0 and you will get A value. A value is minus 1. Similarly, this is the same equation. If you put z is equal to 2, A will get 0, B will contribute as 1. So u bar of z divided by z, A value we got as minus 1 divided by z minus 1, B value as 1. So now this denominator z is multiplied to the numerator of RHS I got. So now I apply the inverse transform on this. If you apply inverse transform, this answer is known to us. What is that answer? We can write minus 1 plus 2 to the power n. Right. Similarly for this, let me try to do phi z divided by 2 minus z, 3z minus 1 it is. Here what you will get if you rewrite u bar of z is equal to phi z, z minus 2, z 3z minus 1. U bar of z divided by z is equal to phi 2 minus z, 3z minus 1. A divided by 2 minus z, 3z minus 1 is equal to A 2 minus z plus 3z minus 1. 1 is equal to yes, cross multiplication. After cross it should be here 5, it should be mistakenly it has came as 1. 5 is equal to A 3z minus 1 plus B 2z minus 2 minus z it is. When you put z is equal to 2, so B will get 0, so it will be 6, 6 minus 1 5, so A value will be 1. So same mistake has happened. 1 by 3 if you put here, it will get as here 3. So supplying these values over here and rearranging this one, applying inverse Z transform on this. So you can see second bracket, it is bit difficult for us. We don't know what is the value of 1 by 3 over here. So what sorry, here you just see this whatever just I will read out for you. U bar of z divided by z is there is equal to 1 by 2 minus z is there. So here we are not knowing 2 minus z, we are knowing z minus 2. So what you will do, you will take common minus. So if you take minus as in common, you will get as minus z divided by z minus 2. And here also the same problem, 3z we don't know, we know only z minus 1. So to take out from 3 into z, I will took as 3 as a common thing. So z minus 1 by 3 will get, so 3 will get cancelled. Now you will get the answer minus 2n to the power n, minus 2 to the power n, 1 by 3 to the power n. Right. So I hope you got my points clearly. Thank you.